logs, we have a couple of properties. Logarithm graphing is, just like I said earlier when we talked about a little bit of this, it is actually pretty straightforward. There's no real craziness or anything thrown into it. It's just a matter of, can you set up the quick log properties. When we talk about log properties, the two I want to keep referencing are log base b of b is 1, and log base b of 1 is 0. Basically, we're going to use those two properties to graph logarithms over and over and over again. So what we have is the generic form, log base b of x minus h plus k. Well, exponential functions had horizontal asymptotes. Logarithm functions are going to have vertical asymptotes because logs and exponents are inverses. Convenient how that works. You are SMRT. Okay. Yes, logs come from vertical trees, not those lazy horizontal trees just lying around all day long. Down. I have 4 days of no bad jokes to make up for. Thanks for the heads up. So you get you get vertical asymptotes at x equals h. There's your vertical asymptote, dotted lines. Domains are always, always, always greater than h. Logs always move to the right. Okay, logarithm equations always move to the right. That's called set notation. It is something fancy that we like to use from time to time. D colon, J Leno space looking left, all values of x, that vertical slash line is called such that x is greater than h, J Leno space looking right. There is a class in college called Draw J Leno Space 103. It's a half credit for elective. It's so how you learn how to draw set notation. That's why you have to take class in it. It's been a few years, so I'm a little rusty. You don't need to use J Leno space for set notation. You can just write domain x is greater than h. I was just showing you something interesting. Interesting. You guys are so boring. Wake up. Your shirt is awesome. If your base is greater than 1, it moves up to the right. If it is between 0 and 1, it moves down to the right.
Very well written.
Thank you. Up and right. Down and right. And that's about it. Logarithms are very, bless you, they're very straightforward in how we set them up. What I like to do a lot with the logarithm stuff, it helps you guys be able to do this without calculator, because all you need to do is come up with 2 points. All you have to do to be able to graph a logarithm is generate 2 points, and as long as you know the direction, you're going to be just fine. So if b is greater than 1, up and right, excuse me. Okay? So let's generate some stuff. Log base 1/3 of x minus 1. So, one thing to remind you of real quick is anytime that there's going to be an h, it'll be in parentheses. The h values will always be thrown in parentheses. If there isn't one, that means there's no h. So in this case, do I have an h? No. There's no h, so that means where's my vertical asymptote going to wind up at? At 0. Very good. Okay. That's one thing that a lot of people forget. I think we've done that before. So this is technically log base 1/3 of x minus 0 minus 1. Okay. That's basically what that means. So it gives you a vertical asymptote at 0. So you draw that first. Excuse me. Our base is between 0 and 1, which means it's moving downward towards the right. But I need to come up with 2 points to figure that out. So what I need to do is figure out values of x to use those. I need to figure out values of x to utilize those 2 properties. So if you think about it, you're just using the base. What's the base of this log? 1/3. So what would be log base 1/3 of 1/3? 1. So what you're doing here is you're using the properties of log bases to generate your ordered pairs to substitute in. So if I know that if I choose a value of x, I do log base 1/3 of 1/3, and then I take that and subtract 1, because that's what this equation says to do. What's log base 1/3 of 1/3? 1. What's 1 minus 1? 0. So that means that I have an ordered pair then at 1/3 and 0. Okay. What's wrong, Trav?
Wait, how did you get 0?
I substituted here.
Oh, okay.
I use this first, and then I just do PEMDAS at that point. And I do the same idea. I'm going to pick 1. Log base 1/3 of 1 is 0. And I get the ordered pair at 1, -1. There you go. Graphing logs is a lot of mental math. You're moving the base. You're just picking values to make the base work.
Well, if you're taking like 1/3 of it, then I saw how you got the 0, but then how did you do the same thing and get 1?
What's log base of anything of 1? Log base b of 1 is always 0. No matter what the base is. So if it's log, that's why these 2 properties are the only ones you have to worry about. If it's log base 1/3 of 1, that means 1/3 to what power is 1? 0. So no matter what, your second order pair you're always going to pick is x is going to be 1. Because then you'll just move your h, or I'm sorry, your k or whatnot. Yes, sir?
I still don't understand how you got 0. 1/3 and 0.
log base 2 of 2 is 1. Log base 1/3 of 1/3 is 1. Okay? What's 1 minus 1?
So
You're using PEMDAS, but you're just dealing with logarithms.
Wait, where does it say log base 1/3 of 1? It says log base 1/3. What that says,
Log base 1/3 of 1.
where did,
Like I said, they're not difficult. It just takes time to get used to. Log base 5 of x plus 2. Log base 5 of x plus 2. Excuse me. Do I have an h here?
yes,
Yeah, I have an h here. Where is it?
-2.
-2, good. So I have an h value of -2. Which means my domain, oh, I forgot to do my domain in the other one. It's going to be all x values that are greater than -2. So I put my asymptote in first. Oops. Okay. And again, I'm going to pick values that make it work. Now I need to think about, I have log base 5 of something plus 2. What plus 2 is 5? 3. See where I'm going with this? So then I choose a value of x at 3. What's 3 plus 2? What's log base 5 of 5? 1. So at 3, it's 1. Okay. I did this one. It's supposed to look right. It's supposed to look like this. We'll do the same idea. How do I make log base 5 of something plus 2? How do I make this in parentheses equal to 1? What do I pick? -1. Because what's -1 plus 2?
Oh,
1. What's log base 1? I'm sorry, what's log base 5 of 1?
0.
0. So that's why I have an ordered pair then at -1 and 0. So it's doing this. And that's what takes time to start to figure out, okay, do I have to manipulate my values to set, do that quick little one-step equation to figure out the value of x that generates your base b of b, makes it a 1. That's all you have to worry about. 2 points. That's it. Direction. Very animated today. Can you please tell both hour to act like this? Great. Let's do it. Let's graph log base 6 of x plus 1 minus 3.
So then is the vertical asymptote -1 or is it
Yep.
-3?
-1. The k value has nothing to do with it. Your vertical asymptote's always at h. So you have vertical asymptote at x equals -1. Your domain is all values of x that are greater than -1. First ordered pair. What plus 1 is 6? 5. Johnny number 5 is alive. So I'm picking a value of x of 5. What is log base 6 of 6? 1. What's 1 minus 3? -2. So at 5, it's -2. What plus 1 is 1? 0. So I'm picking a value of x that is 0. What is log base 6 of 1? 0. What is 0 minus 3? -3. And there's my other ordered pair. My base is greater than 1, which meant, and away it goes. You're selecting values of x to generate these two properties. That's the whole trick for graphing logs. That's all it is. You have to come up with it on your own and go. Yes, ma'am?
How come in the other one, like the H was the asymptote, and then here the K is the asymptote?
The h is still the asymptote. It's at,
Oh, just kidding, just kidding. And this,
because with exponential functions, remember exponentials and logs, they're inverses of one another. So if the exponential had a horizontal asymptote, that meant that logs have a vertical asymptote. That's why that's why it does that. So if you did the inverse of this equation and graphed it, you'd have that line, that imaginary line of y equals x going between the two. Math. Have I mentioned that we're going to start trig soon?
Yeah. Sounds like fun.
It is. Would you like some graphing problems just to tide you over for this excitement?
Yeah, sure. That look good.
Let me use some graphing problems.
Great.
What does natural log stand for again? Log base e. Okay. Could you graph natural log then also?
No.
Remember, natural log is log base e. So you're going to pick values of b that are e. Log base e of e is 1. Log base e of 1 is 0. Doesn't matter that it says natural log, you still use the same properties, it still works itself through. You don't have to generate and put in values of, you're not substituting in decimals for e or anything like that. Okay?